Hi, welcome back everyone. Everyone have a good lunch? I hope you did. Downtown Phoenix, we have all kinds of good places for lunch. So I have the task of waking everyone up this afternoon and talking more about hazard analysis and risk assessments and also different techniques that we can use. So this is going to be a little bit of a participation one. We've turned off the projector, no more death by PowerPoint for a little bit. What I want to do is I want to go through a little quick demonstration of something that we briefly touched on this morning. I want to do a little more of a deep dive. It's called a logic tree. Some of you may be familiar with fault trees. We're going to talk a little more about that. But let's just dive into this. So a logic tree, as I mentioned this morning, it starts with a top event. So let's just go ahead and let's start with the top event of fire. And so let's do our good old buddy, the fire triangle. Everyone remembers the fire triangle, right? Okay, so what is one of the three things that you need for the fire triangle? I'm just going to keep it simple. I know there may be other things that get thrown in, but let's stick with the main three that you probably learned about for when you first heard about it. So what's one? Yes, we need sometime, you said flame, but how about if I call it an ignition source? So we have an ignition source. What's something else that we need? Come on, lunch wasn't that long ago. We have an ignition source. We also need fuel. Yes, fuel. So let's make this easy and simple. Let's say that we are in a gas station and we're going to figure out each one of these. Now there's one more thing that we need to complete this. What is that? Yes. We need oxygen. Someone said air, we need oxygen. I'm just going to say O2. This is our fire triangle. Now, do we need all three of these? Or if we just have one, does it work? We need all three of these. So when we were talking this morning, is that an AND gate or is that an OR gate? It's an AND gate, yes. And so an AND gate is with a flat bottom on it. You remember the OR gate that we had talked about is like this, and we may get to one of these in a second. Let's go ahead and talk about these as we will. Let's just take one of these. First of all, oxygen. Now, I'm using the scenario that I'm at the gas station and we have a fire. I'm putting gas in my car and we have a fire. Okay? So, what's my oxygen source? It's the air, right? So what am I going to do to get rid of the oxygen? Or do I want to get rid of the oxygen? If I get rid of the oxygen, I'll be getting rid of the air, right? So the oxygen is what we're going to call a given condition. A given condition. And so we're not going to develop that one any further. But you do have a lot of ignition sources and you have a lot of fuel. So let's talk about ignition sources. What is an example of an ignition source that you can have? Yep, heard it in the back. We may have a cigarette. Someone may be smoking. There could be lightning. We may also have a flame, as we said before. That can be one. Now, in this case, are all three of these, is this an AND gate where we need all three, or is it an OR gate where any one of these will actually work? It's an OR gate. It's like this. In other words, if we have any of these under the right conditions, it can act as an ignition source. And that can be this part of our fire triangle. Now, I'm not going to develop this much further. You can see the fuel is, we could look at a scenario where you have gasoline pouring on the ground, you overfill, you have a leak in a tank, something like that. But the one thing I do want you to take away from this before we start to go to some of the other techniques is that you can actually show this. And when I was a lead investigator, when I was doing analysis with the Chemical Safety Board, we would actually use logic diagrams like this to actually break it down to some of our root causes. But you can also, once you get down to your basic events, you can also look at the probabilities and the frequencies, and you can quantify this to show how much of a likelihood you will have in a number of events. So I wrote an article one time which quantified a situation before and after we made recommendations to make sure that we showed that the recommendations themselves would be effective. So I just wanted to kind of explain to you how that is. I won't go into that part. If you are more interested in doing fault trees or probabilistic risk assessment, which you can do with this tool, see me at the break and I'll be glad to talk to you. But let's move on to some other techniques.